Hey everybody, Mr. Tannen here, and today we're going to look at a little intro to logarithms. 8.3, I know we need to go over some of your questions from the work from the Thursday and Friday. We'll get a chance to do that tomorrow. So, I'm just going to make a quick video here, but as I could probably tell some of you, right, if I gave you this equation, 3 to the x equals 27, well, you could look at it and say, okay, well, what power of x would give me 27? And it would indeed be the third power, right? But what if I gave you one that was a bit more complex? For instance, I said 3 to the x equals 41. Well, in that case, it's not a perfect power of 3, 41. So you could say, well, I know x to the third is 27 and x to the fourth is 81. So I know x would have to be between 3 and 4. But I don't have an operation to precisely get there. You might say cube root. Oh no, well that's different. The cube root would be in this case, which is not the same. What else could I do? Well, I don't have any operation at this time, but what I could do is I could rewrite this in something called a logarithmic form, where I have the log base 3 of 41 equals x. So, again, the way I would read this is log base 3 of 41. And what that is asking is what power of 3 gives you 41? That's the question it's asking. And so, back in the day, they used to use something called logarithm tables. It was like a big book with all these different powers, and you could look them up and figure out what a logarithm was instead of a calculator. Now I could use my calculator, and there's two ways I could do it. First way I could do is I could do the log of the input for the big number, the log of 41, and divide it by the log of the base, which is 3. This is the way I used to have to do it on my calculator, and you can see it is between 3 and 4, 3.38. On these newfangled calculators, you can also do log base. If I hit math and scroll to log base, I can do it in the way that we would write it, which is log base 3 of 41, and it gives me the same value, 3.38. So, one thing that's going to be important for us in dealing with logarithms is knowing how to rewrite. So for instance, if I had a here, I had log base 2 of 16. Well, if I asked you what this were, I was saying, okay, well, what power of the base gives you 41? What power of 2 gives me 16? Well, 2 to the fourth is 16. So, that is true because, as I just said, 2 to the fourth equals 16. So this is what I would call the logarithmic form, and this would be the equivalent exponential form. And a logarithm is only true because in exponential form that is true. So let me show you something over here. Is to specify these parts of a logarithm. We have a base, we have the input, and we have the output. So the b, we would call that the base. This we would call the input. And then we have an output, or we could call that, as I like to think of it, the exponent, right? Because a logarithm solves the exponent. And here's the equivalent exponential form, b to the x equals y. So here we've got my exponent, here we've got my base, and then here I've got my input there. Not the clearest diagram, but hopefully helpful. So, let's look at a few more examples to help with our understanding. What's the log base 4 of 1? Well, it says, what power of 4 gives me 1? Well, there's only one power that gives me 1, and that's the power of 0. That logarithm is true because 4, the base, to the 0 equals 1. That's true, right? Let's look at C. Log base 12 of 12. So this is saying what power of 12 gives me 12? Well, the first power. And that's true because 12 to the first equals 12. And then lastly, let's take a look at one with a fraction. Log base 1/4 of 4. What power of a quarter gives you 4? What power would have to go there? Well, a negative first power would flip this, so this would evaluate to be -1 because it would give you the reciprocal. I hope this video gave you a little intro to logarithms, and then you can tackle some of these problems that were assigned on the homework. Maybe I'll actually, before I close the video, I'll give you a few more examples of going the other way. So let's see if we can go the other way from exponential to logarithmic. Okay, A. 5 to the second equals 25. Well, the logarithm form will be the log of the base is the base, log base 5 of 25 equals 2. So you'll notice the exponent is always the output because the log allows us to find the exponent. What power of 5 gives you 25? The second. Okay. Logarithm or exponential form here. 10 to the -1 equals 0.1. Log of the base of 10 of 0.1 equals -1. Similar to this one up here, but going the opposite way. C would be 8 to the 2/3 equals 4. Log base 8 of 4 equals 2/3. And lastly, we have D, which is 6 to the -3rd equals 1/216. So the log base 6 of 1/216, which maybe we would like to put in parentheses for clarity's sake, is equal to -3 because 6 to the -3rd is this. So it's saying what power of 6 gives you this, the -3rd power. Hope this was helpful. Nice to see you all. Here's a frog drawing. Have a great day.